Hello and welcome to today's lesson, which will be on powers and roots. So let's start first of all. What is a power? What is a root? And what is the notation used to show them? I've got written out here, I've got 4 examples of the notation used. We've got a big 2 with a little 2 kind of above it to the top right. Same thing going on with a big 4 and a little 3. And then to the right of that, we've got the weird tick with a 25 underneath. And then the small 3 sitting on the weird tick with a 27 underneath. So let's start with the left 2. These are the notations for powers. And what is a power? Well, if we take the example of 2 with the little 2, that means 2 to the second power, or more commonly 2 squared. And what that means is if we take this 2 that I've just circled in red, we want to multiply it by itself 2 times because we've got the little 2 at the top. So for a power, you take the big number and multiply it by itself the little number of times. So in this case, it's 2 times 2, which equals 4. You probably know that 2 squared is 4 already, but that works for any number. So 3 squared is 3 times 3, which is 9. Similarly, 4 cubed here equals 4 times 4 times 4, which equals 64. So as you can see, I've got 3 4s and I'm multiplying them all together. So go on, your turn. Work out with your calculator if you want. 7 squared, 5 cubed, and 3 to the 5th. So beyond to the third power, beyond cubed, we don't have sort of a short way of saying it. We just say to the whatever power, or just to the whatever. So in this case for 5, it's to the 5th. So once you've had time to do that, you should find that 7 squared is 7 times 7, which is 49. 5 cubed is 5 times 5 times 5, which is 125. And 3 to the 5th is 3 times 3 times 3 times 3 times 3, which equals 243. And I'll make that 2 a bit clearer. There we go. Somewhat better. So now let's go on to the other notation, which I had above as weird tick with 25. And then, 3 on a weird tick with 27 underneath. This is the notation for roots. And this one on the left, you may well have seen it before, but it's the notation for a square root. And the square root of a number is the number that when multiplied by itself gets you that number under the square root, which I will circle in green, like so. So for example, the square root of 25 is, what do I have to multiply by itself to get 25? The answer is 5, because 5 times 5 equals 25. So the 5 squared therefore equals 25. So square root of 25 equals 5. Some people will just say root 25 if there's no clear degree. Similarly, the symbol doesn't have any number indicating which root. Assume it's the square root. And then here we've got the little 3. Obviously we've got the 27. So we know that ultimately we're finding something that multiplies to make 27. But we also got this little 3. And what this little 3 means that we want, instead of the square root, we want the cube root. So we want the number that when multiplied by itself 3 times gets us 27. And in this case, the cube root of 27 is 3, because 3 times 3 times 3 equals 27. So 3 cubed equals 27. And the cube root of 27 equals 3. So go on then, again, your turn. Feel free to use your calculators if you can find the buttons. Work out the square root of 64, the cube root of 216, and the fourth root of 81. So again, beyond 3, where we say cube root, we just say whatever root, so 4th root, 5th root, 6th root, etc. So hopefully you've now had time to do that. You would find that the square root of 64 is 8 because 8 times 8 equals 64. The cube root of 216 is 6 because 6 times 6 times 6 equals 216. And the 4th root of 81 is 3 because 3 times 3 times 3 times 3 equals 81. And as we've seen, we can shorthand all of these. That's 8 squared, that's 6 cubed, and that's 3 to the 4th. And you can see that the small number in superscript down at the bottom here matches the number kind of in front / on top of the root sign in the initial question. As we've said, because there's no number on the square root, we assume it's a square root. You could write it like so with a 2. Okay, so finally for this video, I'd like to cover the laws of powers. There are 3 laws of powers, and the first one is this. If I have a number a to a power m, and I multiply that by another number, the same number a, to a different power n, I get a to the m plus n. So where a is known as your base in this case, it's the number you're multiplying by itself however many times. M and n are your indices, your exponents, your powers, whatever you want to call them. They're all the same word for the same thing. And let's show why. So if we take 2 cubed times 2 squared, well, what is 2 cubed? We know that 2 cubed is just 2 times 2 times 2, and we know that 2 squared is just 2 times 2. And as we can see, we've got 5 2's all multiplied together, so that just equals 2 to the 5th, and 2 to the 5th is 2 to the 3 plus 2. That's what it is. So equally, if I have a cubed times a to the 4th, that's just going to be a times, oh, I can't write a anymore, a times a times a times a times a times a times a, where there's your a cubed, there's your a to the 4th, and you get the whole thing is a to the 7th, which, as we know, is a to the 3 plus 4. So the second rule is that if I have my base a again to some power m divided by my same base a to some power n, that is the same as a to the power of m minus n. So if we show that again, let's use the example we had earlier. If we have 2 to the 5th over 2 cubed, that equals 2 times 2 times 2 times 2 times 2 over 2 times 2 times 2. You could work this out. This is 32 over 8, which gets you 4, which, as we know, is 2 squared. Equally, if you have a fraction like this and everything is a multiplication or a division, you've got no addition or subtraction, you can just cancel anything that's the same. So I'm multiplying by a 2 here and then dividing by a 2. So we know that multiplying and dividing by the same number gets you where you started. And we can do that again and again. So we can cross off, this is cancelling out the 3 2's on the bottom with 3 of the 5 2's on the top, and we just get 2 times 2 over 1. We have to keep something on the bottom because we can't divide by 0. It would be 1 because you're effectively dividing by the 2's. And we know that anything divided by itself is 1. So you get 2 times 2 over 1, which, as we know, is 2 squared, which we can see is 2 to the 5 minus 3. And again, that will work for any base. If you have a to the 5 over a to the 3, you will get a squared at the end. Finally, the last power rule is if I have some number a to the power m and I raise that number to another power n, that is the same as a to the power of m times n. Again, you can shorthand write this. You'll see this quite a lot as just mn. This is algebraic notation. Multiplication can just be shown by basically pushing the unknowns together like that. So again, to give an example, let's say we have 2 squared and we want to cube that. Well, we know that 2 squared is 2 times 2, and we're cubing that. So what we need to do is multiply 2 times 2 by itself 3 times. So that's going to be 2 times 2 times 2 times 2 times 2 times 2. And that gets us 4 times 4 times 4, which is 4 cubed, as you'd expect. But equally, because everything's being multiplied here, you can see we're just multiplying by 2 by itself 6 times. So that is 2 to the 6th. And as we know, 2 to the 6th is 2 to the 2 times 3, because 2 times 3 is 6. So I'll write these out again. So if you have a to the m times a to the n, so some base to a power times the same base to a different power, it can be the same power, but to another power, equals a to the m plus n. If you have a to the m over a to the n, that is a to the m minus n. And if you have a to the m to the n, that is a to the m times n. So these are the 3 rules of powers that you need to know. I will be referring back to them in my next video, which will be on fractional and negative powers, because so far we've only covered powers that are positive whole numbers. And once we start looking at fractional and negative powers, I will be using these 3 rules to explain why the fractional and negative powers are what they are, effectively. So, finally, your turn. I want both the actual numerical value and the power form of 2 to the 4th times 2 cubed, 3 to the 7th over 3 to the 4th, and 4 squared. That. So obviously, again, pause the video, give yourself time to work them out. And once you've done that, you should get the 2 to the 4th times 2 cubed should be 2 to 7, as we know, and if you evaluate that, you get 128. Evaluate, if you haven't heard the word used before, just means find out the actual numerical value. So if you're told to evaluate a sum, what it means is just work out what the answer to the sum is. Okay, 3 to the 7th over 3 to the 4th is just going to be 3 cubed, because it's 3 to the 7 minus 4, which, as we saw earlier, is 27. And finally, 4 squared. Squared is going to be 4 to the 4th, because it's 4 to the 2 times 2. And that works out as 256. So I hope you enjoyed this video. If so, please like and subscribe. My next video, as I've said, will be on fractional and negative powers. Very exciting stuff. But until then, look after yourselves and have fun.